Okay, welcome to another Ginger Mathematician video. So I had a request to do a specific paper 6 that someone's having trouble with, so stay tuned, I'm going to go straight through it. Okay, so welcome to this paper 6 video. So I'm going to walk through the November 2020 paper 6.2. Notice this is slightly different to some of the older papers. The first thing to notice here is that the paper is 1 hour and 40 minutes long. It's an extra 10 minutes compared to a couple of years ago. Notice the paper is now out of 60. So there's a couple of changes that they've made on Cambridge to make your life actually a little bit easier. So essentially more time. The marks are more as well compared to say paper 2 for example, and you'll notice now as we go through the questions, each question is actually marked very clearly how many marks it is. So that's going to make our lives a lot easier. You're going to need a graphic display calculator, although a normal calculator will work for the investigation because we are going to go through part 1. Again, before I get started, please like and please subscribe, particularly if you want more paper 6 videos before the exam on Tuesday, then please let me know. Right, let's get started. So question 1, a nice warm-up question. Our investigation this time is based on the area of right-angled triangles, and we're given a couple of formulae, how to work out the perimeter of a triangle and how to work out the area of a triangle. These formulae you need to be aware of. Notice they've changed the notation slightly, so our W here is the hypotenuse of our triangle, not the H here. So just keep that in mind as we work through some of the problems towards the end. So question 1a, we're given a triangle and we want to work out the perimeter. So we can just use the formula here, base plus height plus the W, the hypotenuse. So essentially we just add these three numbers together. So we just do 3 plus 4 plus 5, and that's equal to 12. And then to work out the area of the triangle, well, we need to do half base times height. Okay, so what's our B and H? If we look at our triangle, well, that's the 4 and the 3. So we just use the formula. So you've got a half times 3 times 4. Again, you can use your calculator, of course, but 3 times 4 is 12. A half of 12 is 6. There are no units here, so we just write down the number 6. Okay, let's continue. I promise you the questions will get harder. So we have a very typical paper 6 kind of question where we have a table and we need to fill in the missing gaps. So these are ones you need to be getting right to make sure you're getting the grades that you need to get. So complete the table for the right angle triangles with sides B, H and W. So for this one here, we need to work out the perimeter where you have a B of 84, an H of 13, and a W of 85. So to work out the perimeter, so for this one here, we're just going to do 84 plus 13 plus 85. Okay, and then just work that out. Now, you can just use your GDC. Again, you can always double check that you're doing everything correct by using your GDC. So if you just type it in, we have 84 plus, move it across slightly, 13 plus 85, and then that gives us the perimeter, which is 182, like so. And then the area here, well, remember area is half base times height, so these two figures here. So our B and H in this case is 84 and 13, so then we just do a half times 84 times 13. It is worth writing your working as well because you'll pick up communication marks as you go along. So I'll go back to my calculator, and we just go 0.5 times 84 times 13, and then we get the answer of 546. So we pop that in, 546. Okay, and they'll ask you to work through the table in slightly different ways as well. So for this one here, I think you can use Pythagoras' theorem, of course. But I think the way I would do this is I know the perimeter already, so I know this is 56. So to work out H, I can work backwards. I can do 56 minus 24 minus 25, and that will be equal to 7. Again, check on your graphical calculator if you so wish. And I would do the same trick here as well. So the perimeter is 132. How do I work out W? Well, the way I would do that is just do 132 minus 60 minus 11. Again, if you're ever unsure, if you don't want to do the mental calculation, that's absolutely fine. See what I'm doing here. You lose no marks for using your calculator. So we have minus 60 minus 11 is 61. And yeah, you'll be tense in the exam, so make sure that you use your calculator wisely to take any of that tenseness out of the question that you're doing. For the area of the triangle, we just do base times height divided by 2. I've got 61 here. So when we just do 60 times 11 times a half, remember multiplication you can do in any order. So if we do that, 60 times 11 times a half, again, just using my GDC, yeah, that's what it's there for. So 60 times 11 times 0.5 is 330. And then we pop that in. You do not want to be losing marks on these straightforward questions. So 330. So there's our answer for 1B. Just show you the mark scheme here. So you get 1 mark for only getting 3 or 4 correct white cells, and you get the full 2 marks for everything correct. So 182, 546, 761, and 330. Notice the communication marks are not separate anymore. They're involved within the question. So showing any relevant calculation will give you that C1 mark. So I was a bit overkill here. I put down every single bit, but you have the extra time, so please do use that to make sure you get all 3 marks. Okay, question 2. So they tell you the perimeter has P equals 60. Now, I'm not trying to trick you. It definitely does have 60. 26 plus 24 plus 10 is equal to 60, so everything is good. And show that the calculation 60 over 2, okay, it's kind of bizarre, times 60 over 2 minus 26 gives the correct area for this triangle. Okay, now this is a 3-mark question, so you need to treat this with respect. First of all, we're going to use the half BH formula, so half BH, because that's how we normally work out the area of the triangle, like we did in question 1. And this then would be a half times 24 times 10. Again, you can use your calculator to do that, or otherwise, you'll see you get the area of 120. So you need to show this. So you can't just write down it's 120. You need to show with this formula is equal to 120. And now with the formula above, I'm going to show that now as well. So I'm going to write it down. Just don't miss out on these communication marks. Yeah, they're vital to getting full marks on this exam. Well, 60 over 2, or 60 divided by 2 is 30. 60 divided by 2 is also 30. And minus 26. And then we do the brackets first, so 30. It's going to stay the same for the moment. Now 30 minus 26 is 4. And then 30 times 4 is 120. So I've shown the examiner using the formula from before, gives me 120. And also the formula given gives me also 120. So these two answers agree with each other. 3 marks. They don't give out 3 marks or nothing on this exam, so make sure you are getting it. Right, let's move on to B. So this time the triangle has perimeter 112. Show that the calculation given below gives the correct area for the triangle. So this is slightly more on the trickier side. You could use Pythagoras to work this out, for sure. Again, keep it simple. You know the perimeter is 112. You're told this. So to work out the missing h here, this missing side, we're just going to do the perimeter, 112, minus the 2 sides we know. So minus 50 minus 48. And again, we can work this out with a calculator or not. Okay, both are absolutely fine. And then you'll get the answer of 14. Again, always double checking to make sure you get the right answer. So this is equal to 14. Pop that in. And then we use the same formula that we did before. So it's slightly increased in difficulty. So we're going to use a half BH. Same thing we did before. So a half times 48 times 14. Now this one I would do on my calculator just to make sure I'm getting the absolutely correct answer. So I get 0.5 or a half, you can type either, times 48 times 14. That gives me 336. Perfect. And now we're going to use the formula above. So we've got 112 over 2 times 112 over 2 minus 50. Okay, well, again, you could work this out on your calculator. I'm just going to do it quickly and put 56. Okay, if you're not sure where 56 come from, just do it on your calculator. This is also 56, 50. And so this gives us the calculation of 56 times 6. Again, you can use your calculator to work this out, but this will actually be the same as the answer given, which is 336. I love these kind of questions at iGCSE because you can confirm you have the correct answer. Okay, so I think we'll do a quick look at the mark scheme now. Yep. So notice I've done this exactly the same way as the mark scheme. I'm getting all 3 marks here. So I've shown it using half BH. I've shown it using the formula given and got 120 twice. And I've done exactly the same on 2B. I haven't missed any mark out. And if you didn't put that down, then you might get 4 marks out of 6 rather than 6 marks out of 6. And being a small paper, that makes a big difference. Okay, question 3. We've got now a typical completing the table question for 4 marks. So again, this is a more complicated version of what we've seen. Now, remember this is a non-linear paper. So what do I mean by that? Well, we've already done this question here. So notice this is the first row for us to complete. This was actually this question here. So notice it's the same question. So we already worked out h was 14. So I'm going to write that in. And we already worked out the area of the triangle, which was 336. So really do use the idea of the non-linear paper to make your life easier. And likewise, this calculation, this is the one that we did before, is also 336. Again, I'm always looking for patterns in this kind of paper. And notice that the area 120 is the same as a calculation here. The area 54 is the same as the calculation here. So I'm using that to save some time. If we do the next row, I'm going to show my working here. So to work out the perimeter, we just do 15 plus 8 plus 17. Okay, and if we work that out, I think we get the answer of 40. So I'm going to pop 40 in here. And then I'm going to look at this question and think, okay, where does this perimeter 40 fit in this calculation? And notice the numerator of both these fractions is equal to the perimeter number here. So I'm going to write this slightly bigger because it won't fit in. So this calculation here will be 40 over 2, open brackets, 40 over 2. So I'm just copying the first part and looking for the pattern. Got 60 here, got 60 here, got 36 here, got 36 here. And then I think about where this number comes from, and I realize this is the number of W here, 26, 26, 15, 15, 50, 50. So this calculation here is going to be minus whatever the W is, which is 17. And if I was in the exam, I would check that this calculation actually does give me 60, which it does, because this is 20, 20 minus 17 is 3, 20 times 3 is 60. So I'm always checking my work as I'm going through. So that is equal to 60. Once I start seeing these patterns, then I can start applying it to these questions. So if I look at this one, again, I can use the perimeter to work out the missing value. So I can do 70 minus 21 minus 29. And that's going to give me 20, I think. Again, I'm always double checking. 41, 61, 70. Yep, I'm happy with that. That's going to be 20. And then this calculation, I'll try and fit it in here. So we've got all the other information. This number is the same as this number, so this is going to be 210. And then we're going to do the formula. So it's that perimeter number that's always the same. So we get 70 over 2, 70 over 2, minus whatever W is, which is 29. And I would also double check this, so 35, that's going to be 35 times 6, which is going to give me 210. So everything works. For this one here, this is a bit trickier because I've got a couple of missing values now, P and B. The way I would do this is I've got the area here, 210. Now I know the area is equal to a half base times height. And I know some of these values. I know the height is 12. So a half times B times 12 is equal to 210. And this is simply an equation to solve. So I'm then going to get, if I times by 2 on both sides, to remove the fraction, that gives me then 12b is equal to 420. And then I think to myself, okay, is that going to give me a whole number? Well, I can always use my calculator if I'm not sure. And so far these have all been whole numbers, so I'd be surprised if it's not a whole number. If I divide by 12, this disappears. 420 divided by 12. Now I know what the answer is, but I'm showing you on the calculator what you do. 420 divided by 12, and we're going to get 35. Okay, all good. So go back. 35. So B is 35. The thing is, this is a question we already did. No, it isn't. Okay. So 35, 12, 37. To work out the perimeter here, I'm just going to add these together. So 35 plus 12 plus 37. So this gives us then 47 plus 37. And that's going to give us 84. Again, all this you can check on your calculator. And then we're going to use the same pattern that we saw before. So we've got 84 divided by 2, open brackets, 84 divided by 2 minus W, which is 37. And that's going to equal the same number as the area, which is 210. And again, actually I'm going to show you this actually on GDC. I'm actually going to check this. This is exactly what I would do in the exam. So I have control fraction 84 divided by 2 times, open brackets, fraction again, close bracket, and I get 210. So I want to guarantee I'm getting every mark by just checking my calculations as we go. Okay, and on to question B. So we need to write an expression for the area of a right-angled triangle in terms of P and W. This is now just formalizing what we've already seen. So we know the calculation here gives us the area. This 60 represents the perimeter, so we can write down then P over 2, but it's always over 2 for every single question. Open bracket. This 60 also represents the P every single time, so we can write down P over 2. And then finally, this number always represents the W from this column. So our formula, again, using the patterns we recognized in 3A, gives us then P over 2 times, in brackets, P over 2 minus W. Okay, so mark scheme there, so you can check all the values that I've worked out here. And you can see the formula at the bottom. I didn't put the times in. I think that's potentially bad algebra, but you can if you wish. Notice I use this formula here for my communication rather than this one here. I think that's slightly on the simpler side as well. Okay, so on to part C. So using the expression from part B to find the area of this triangle. So again, non-linear paper, we go back to this expression we just wrote down. So I'm going to copy it over. P over 2, open brackets, P over 2 minus W. And I want to use this expression to work out the area of the triangle. So 4 marks, so there's going to be some working involved here. First thing I notice is I'm actually missing my W in this triangle. So we need to use the theorem above, Pythagoras' theorem, to work this out. So W squared, just copying this formula, equals B squared, which is this number squared, 56 squared, plus h squared, which is this number squared. So 33 squared. So if I work this out on my calculator, 56 squared plus 33 squared, and showing all my working, very important, so 56 squared plus 33 squared gives me 4,225. Again, always writing your steps in paper 6. And then think, what's the opposite of squaring? Well, that's going to be square rooting. So we're going to square root both sides. This cancels with this, so we get w equals the square root of 4,225. I get the feeling this is going to be a whole number, which has generally been in this question so far. Again, I can kind of cheat on here. I can go Control, square root, and then just click the answer button. I'll take my previous answer, and then we get 65. So we know this is equal to 65. So I'm going to write that in. Before we can use this expression, we also need to work out the perimeter of our triangle. So we need to add together 33, 56, and 65. Okay, so that gives us 89 plus 65. And if we add those together, I'm going to get 154. Again, I'd always check this on the calculator if you're not sure about the adding here. And now we know what P is and we know what W is. We can then actually pop this into our formula. So we get 154 over 2, brackets 154 over 2 minus 65, which is this W here. And I'm going to put this into my calculator. So I'm going to quickly do this. So fraction button, 154 divided by 2, multiplied, open brackets, another fraction, 154 divided by 2 minus 65, close brackets, we get 924. Now, even though I may not write this down, I would also check that my normal formula also holds. So I'm going to do this as an aside. I probably wouldn't write this down in the exam, but I would certainly check whether a half times 33 times 56 gives me the same answer. Again, just as a double check, making sure I'm not making any mistakes. So 0.5 times 33 times 56 gives me 924. Yeah, so I'm happy with that answer. And this one now takes it into a more algebraic way. So show your expression from part B works with right angled triangles with sides 3k, 4k, and 5k. So again, we write down the formula from part B. This was the P over 2 minus W. This is the formula. In order to use this, we need to identify what W is. Remember, it's the hypotenuse, 5k, and that P is equal to all these added together. So 5k plus 4k plus 3k, that gives us 12k. Okay, and then we just put this into our formula. So wherever we see a P, we put a 12k, so 12k over 2, 12k over 2 minus 5k, and we just want to simplify this now, so 12k divided by 2 is 6k, 12k over 2 is also 6k, 5k, and then we work out the bracket. Remember BIDMAS, 6k minus 5k is simply k. Remember, when we've got algebra next to each other, we're multiplying, and this gives us 6k squared. And notice, if we use the old formula, again, I'm going to do this as an aside, I'd always check this in the exam, then it would be a half times 3k times 4k. That will give me a half times 12k squared. A half of this is 6k squared. So I've used the formula correctly. Okay, so there's the mark scheme. As you can see, I'm trying to pick up all these method marks as we go along. There is some follow through here. So say you got 65 incorrect, then they would still give you 2 method marks, essentially, or communication marks. even if you use the incorrect value in the correct way. So keep that in mind. Okay, and this is where it gets a little tougher at the end. So with question 4. So an isosceles right-angled triangle has sides x, x, and 10. Now this is important. Isosceles means two sides are the same, or two angles are the same, and right-angled. So the only way we can draw this particular triangle is it has to be a right-angled triangle, like so. Now two of the sides have to be the same, so these must be the two shorter sides, so x and x, and therefore the hypotenuse has to be 10, because if this is x, for example, there needs to be another side that's also x, and that can't happen. So this is the only way that you can actually draw this triangle, and we need to use question 3b to find an expression for the area of the triangle. Again, that formula from 3b, non-linear paper, let's go back. We're going to be using this formula to work out the area of the triangle. Right, so let's write down the formula. P over 2, P over 2 minus W. So let's work out what the perimeter is. So the perimeter is all these added together. So we've got 10 plus x plus x. Well, we've got two x's, so we just add those together. Okay, W is equal to the hypotenuse, which is 10. And now we just put it into our formula. So we get 10 plus 2x over 2, open brackets, 10 plus 2x over 2 minus 10. Okay, and he wants it in the simplest form. So there's going to be a little bit of algebra now to actually get this in the simplest form. The first thing to notice here is because it's both divided by 2, we can divide each of these by 2 as well. This is not bad cancelling, you are allowed to do this. So 10 divided by 2 is 5. 2x divided by 2 is equal to x. So we get 5 plus x. Okay, and we get the same value here. So we get 5 plus x. I'm going to put this in brackets. 5 plus x minus 10. So if we work this out, we then get 5 plus x is going to stay the same for the moment. And 5 plus x minus 10, well, 5 minus 10 is equal to minus 5. So we get x minus 5. Now, I'd be happy that's in your simplest form, but you could also multiply this out using FOIL. So I'll do that as well, guarantee their method marks. So remember FOIL, first, outside, inside, last. So if we do this, 5 times x is 5x. Outside, 5 times minus 5 is minus 25. X times x is x squared. And x times minus 5 is minus 5x. These cancel. We've got 5x and a minus 5x. So this would also be equal to x squared minus 25, a difference of 2 squares. And using that answer, so x squared minus 25, this convenient answer, and the formula for the area of a triangle to find the exact value of x. Okay, so we've got our x squared minus 25. Now, if we use our normal formula on this triangle, the normal half BH formula, then we get a half times x, which gives us a half x squared. So these two formulae, the normal one and this kind of strange one, must be the same. So the result must be the same. So we can make them equal to each other. In this case, we just got an equation to solve. So the way I'm going to do this is minus a half x squared from both sides. Try to get all the x's on their own. So 1x squared minus a half x squared is a half x squared. 25 stays the same. And these two things cancel. This is the whole idea. This gives us 0. Then I'm going to add 25 on both sides. Again, I want to get x on its own. So this cancels here. We get a half x squared is equal to 25. Again, want the x on its own. The opposite of timesing by, of a half here is timesing by 2. Again, the whole point is cancelling these things, because 2 times a half is 1. So this cancels. We get x squared is equal to 50. And therefore our answer, well, what's the opposite of squaring? Square rooting. So we get the answer of root 50. And usually when you square root, you get 2 answers, but this is talking about triangles, about real lengths. So you're just going to take the positive answer. And well done if you spotted this. You can actually simplify this third. Don't think it's necessary actually to 5 root 2. Because remember, root 50 is the same as root 25 times root 2. I don't think that's necessary. Let's quickly check the answers on that. I think root 50 is fine. Yeah, root 50 is absolutely fine there. Okay, all good. Okay, and part B, we're now going to generalize even further here by using even more algebra essentially. So by writing u equals b plus h and your expression from 3b, we're still using 3b. Where is it? Yep, this expression here, still using this. Find an expression in terms of u and w for the area of any right-angled triangle. Okay, so let me write down that lovely formula again. So p over 2, open brackets, p over 2 minus w. So before we can do anything, we need to work out what p is. So the perimeter is just added together. So we get b plus h plus w. However, in the question, we're told that we want to write u equal to b plus h. So we're going to replace the b plus h with u. We get u plus w. So that is our perimeter. W stays the same. We want that in our formula. So wherever I see a p, I'm going to replace it with a u plus w. So let's do that. So this is going to be equal to u plus w over 2, open brackets, u plus w over 2 minus w. Yeah, and this is slightly tricky to work out. Yeah, this is not straightforward. So we then need to think how are we actually going to approach this. I think the way I would go about this is probably just multiplying out the bracket. We could simplify the bracket inside first and then multiply. Yeah, when I did this earlier, I just simplified the bracket inside. Let's do that. So there's more than one way of doing this. What I'm going to do is split this into 2 distinct fractions. So I'm going to split this into u over 2 plus w over 2. Okay, so I am allowed to do this, minus w. If I split this, I can then simplify the w's. So u over 2 stays the same. Remember that w over 2 is the same as a half w. So a half w minus 1 w is minus a half w. So minus w over 2. And at this point, now I've got denominators the same, it's going to make my life easier. I can actually just multiply out the single bracket. We could have done this earlier as well. So if we multiply the single bracket, we have to be careful. Remember, we have to multiply numerators, denominators. So we get u plus w, u, over 4. Remember, you have to times these together as well. Minus u plus w, w, over 4. And at this point, we can actually combine the fractions. This is the way why I did it this way. So we can actually put the fractions together because they're both out of 4. I'm going to multiply out the brackets. So we get u squared plus uw minus, well, minus applies to everything here. So u times w is uw. And minus w times w is minus w squared. Again, this can all be written over 4. And the great thing about this is these two things cancel, and we're left with our answer of u squared minus w squared over 4. Okay, so let me write that down here. So u squared minus w squared over 4. The mark scheme has also got it as a difference of 2 squares as well. And the very last part here, the very last question, use Pythagoras' theorem to show your expression from part 1 gives a half BH for all right angled triangles. Okay, so notice we don't have B or H in this formula whatsoever. So we need to make sure we can pop it in. The first thing that we know is that substitution from before, so this substitution. We know that U is equal to B plus H. However, we don't know what W is in terms of B plus H. However, we can use Pythagoras' theorem. So Pythagoras' theorem says that W squared is equal to B squared plus H squared. And notice we've got a squared in here, so actually we don't need to square root this. So we can leave this as W squared is equal to B squared plus H squared. So essentially, we're going to take this formula that we just got from the previous answer and substitute these two things in. Okay, so I'm going to do it on this page, so I've got a bit of room. So we've got U squared minus W squared over 4. We've got U is equal to B plus H, and we have W squared is equal to B squared plus H squared. So let's put them in. So U is equal to B plus H, so we get B plus H all squared, minus W squared, so minus, open brackets, B squared plus H squared over 4. This is a double bracket, so remember, B plus H squared is the same as timesing it by itself, so B plus H times B plus H. So we get B squared. I'm going to do FOIL fairly quickly here. So BH plus BH is 2BH plus H squared. Now remember, this minus applies to both of these things. So we get minus B squared minus H squared. Almost there. Over 4. We've got some lovely cancelling here. So this cancels, this cancels, this cancels, this cancels. We're left then with 2BH over 4, and then 2 goes into both of these, 2 goes into 2 once, 2 goes into 4 twice, and we get the formula we wanted, which is BH over 2. Okay, they want us to rewrite that, so as a half BH, like so. And we've demonstrated that by substituting into the formula, we do get the formula that we're all used to using half BH. So just show you the mark scheme there. So I use this substitution here. So W squared by B squared plus H squared, as well as this one. For 1 mark, that's pretty tough. I would give 2 marks for that personally, but this is what the mark scheme wants you to do. So that's the investigation part of this paper. Again, if you like the content, please do like the video. That gives me more feedback, essentially. You want more paper 6s, particularly before the exam on Tuesday. And hopefully at the end of the week, I'll get a chance to look at the modelling section of this paper too. Right, see you later, and bye-bye for now.